Hi everyone, today I am going to explain one project end to end. This is a small Spring Boot application which is backend by the MySQL database. So let me show you that project, that application first. This is the small web application which has total 3 pages, like one login page, one registration form page, and finally who are the users registered with this application page. So let me show you. Just now I have already registered and I have added some users also. Let me show you how this registered users page is going to look. This is the registered users page. Like these are the users already registered with this application. If you want, we can register a new user also, like devops@gmail.com. Okay, let me log in with this. So like this, we can register number of users with this application and we can access them, their details. Okay. So first of all, I will explain the complete concept of this project. This application source code will be placed in GitHub, and from the Docker server I am going to create one Jenkins container first, and already I have created Jenkins container. In that Jenkins container I am going to run a declarative pipeline to build and Docker image and run these containers, like application container as well as MySQL DB container. And after that we have to perform some stages, like we are going to perform some stages like testing, SonarQube static analysis, and after that we will deploy this artifact into the Nexus repository, and Docker we are trying to push the Docker images into the Nexus repository. Finally, we'll do some cleanup process, like we'll remove the unused Docker images or dangling images, like that. So this is the concept of the project. Let me show you. This is my Docker server. Let me show you the images already. These are the images, and let me show you the containers what are running. Already I have run this project successfully, so that's why it is pushed these Docker images to the Nexus repository. And there are 3 containers. They are up and running state. One is Jenkins container, and second one is MySQL DB container, and third one is Spring Boot application container. Okay. Let me show you this pipeline script. This is my declarative pipeline script. Here I am going to I have created all these environment variables for solving the purpose of different stages, like Spring Boot image and Spring Boot container, MySQL image container, like this, MySQL database, MySQL port number, and Spring Boot Spring data source URL, Docker network, Spring Boot port, SonarQube URL, Nexus Docker repo, Docker image, and Nexus release repo, Nexus snapshot repo, like this. Like this, there are different environment variables which are going to use in this pipeline further. So there are what are the stages? Let me show you in the graphical way. You can have a better idea. So this is my Jenkins pipeline. works. See me. There is some noise behind. Okay, this is my pipeline in graphical way. These are the total stages are there in this pipeline: cloning repository and creating Docker network and starting MySQL container, and it will wait for MySQL up and running state. Once it is up and running, then it will going to build the Spring Boot application Docker image, and after that it will start the Spring Boot application container as well as. After that it will check the application is running or not. It is going to check the health of the application. Finally it will test the application, and further it is going to check this. It is going to do the SonarQube static analysis. After that it will deploy the artifact into the Nexus repository based on this version. If it is snapshot version, it will going to store in snapshot repository, and if it is release version, it will going to store in release repository. After that it will push this Docker image what we have built in this stage. It will push that image into the Nexus repository which is created for Docker images. So finally it will do the cleanup process, like it will delete these unused images or any dangling images are there. It will clean up this in this stage. In the stage 1 like this, it will cloning the source code from the GitHub, and it will create the Docker container network. Here it is going to start the MySQL container. Once it is created, it will check, it will wait for some time to check it is up and running state or not. Once it is up and running, then it will going to build the Docker image which is regarding this Spring Boot application container. So once this image is ready, it will run the Spring Boot application container, and once application container is ready, then it will check the status of that application, whether it is running correctly or not. Like this, it will check the status. Here it will check once this application is up and running, it will pass, otherwise it will exit from it will fail the pipeline. After that we will test the later part. We are going to do the SonarQube static analysis like this. Here let me show you Sonar. This is Nexus. Okay, sorry, this one. Okay, this is my SonarQube server. Yeah, this is the registration login demo application what we have created now. So this is the status of this overall code status. Overall code static analysis is all this data regarding this project. So there are 0 bugs, vulnerabilities are 0, 1 security hotspots 1, and depth 43 minutes. There are 9 code smells, and code coverage is 33.6%. Because I didn't perform code coverage in this pipeline, I will do later. I will integrate that one also. And duplication of this is 0%. Okay, this is the 0.0.1 snapshot version. This is my SonarQube static analysis already successfully run. So you can check here. Last 1 hour back I have built this one. Okay, let me show you the Docker sorry, let me show you the Nexus repositories also. This is my release repo. Actually, I didn't run any releases. I run the snapshot version. So it is successfully deployed this artifact into my repository, which is registration app snapshot repo. Okay, and let me show you the Docker images repository also. This is my Docker host repository. This is our Spring Boot application. So this is a manifest file and the tag is latest. Like this, it is going to push the Docker images into this Nexus repository. We can check it here also. This Spring Boot application is pushed to the Nexus repository. Here 3.85.30.4, which is our Nexus repository URL. Okay. Like this, it is going to execute the project. It is successfully created it is successfully performed all the stages. So let me run one more time. I have executing this pipeline one more time. So this is successfully already completed cloning the repository stage, creating the Docker network, and creating the MySQL container, and MySQL container is up and running also. And now it is building the Docker image. It will take roughly 4 minutes to complete this entire pipeline. Yeah, our Spring Boot application is successfully running. It is created and it is checking this application health. Once it is running perfectly, it will complete this stage and it is going to test this application. So it takes some time. Before that, let me explain some important things. Yeah, verification also completed. It is testing. Now it is performing the SonarQube analysis. Roughly it is taking 40 seconds to do this one. Once it is completed, I will explain some more important points. Yeah, now it is deploying artifact into our Nexus repository. Now we can check our SonarQube project. Just before we have run 1 hour ago, right? Let me refresh this one. You can check it now. 40 seconds back, this analysis has happened. So successfully it is done this SonarQube test static analysis. This deployment of artifact into Nexus also successfully completed now. Let me go and show you. Sorry. Yeah, this is one. This one just now performed. You can check this at 5:10. Okay. Now it is pushing the Docker images. Already it is pushed successfully. Let me show you that one also. This is the image. Just now it is pushed. Okay, 525. I keep showing 525. Sorry, this one is recently pushed one. Okay, 510. Some noise is there. Okay, in the final stage it is going to remove some dongling images or unused images. So to clean up purpose, it is reclaimed the space almost 300 and 200 500 MB like that, and it will delete the workspace when build is done. It is deleting the project workspace, so that one also integrated in the cleanup stage. Okay, and let me show you some crucial steps in this process, what we have to do mandatorily. Yeah, I have configured my GitHub SonarQube Nexus repository credentials in Jenkins credentials. Let me show you that one also. Let me go back to the classic mode. Total run is 3 minutes 10 seconds. This build total run is 3 minutes 10 seconds. Okay. Yeah, in these credentials I have already created credentials for my GitHub, SonarQube and Nexus credentials. In SonarQube I have created I have generated a Sonar token and I have saved it as secret text in these credentials, and Nexus I have saved my user and password. For Git I have saved GitHub token and username. So like this we need to store our credentials first, because in this project we didn't hard code any credentials like that to keep our credentials in a safe manner. So everything is going to happen through environment variables only. So we'll never show our username and password details like that. So for that purpose we have to use these Jenkins credentials. That is the point 1. And after that we have to create an empty project before going to run this pipeline, because once we have created a project and we have to set the project key for this pipeline, we will use that project key as an environment variable to do the static analysis. So let me show you here. In this project just we have to create a project, display project name and project key also. Same project, we can make it same as project key also. So that is the step 1. And after that we have to set some settings here, like in the security. This is the key generation where we have to generate Sonar token. Here we have to generate our Sonar token, and this token will going to save in our Jenkins credentials. Okay. In this project administration, we have to set permissions, global permissions, like to execute analysis, that what are the user we are going to store in our credentials. That user must have the execute analysis permission. So please make sure that user has this permission or not. If he don't have that permission, give that permission to that user, then only he can able to run this, otherwise build will be failed. So 3 things in the SonarQube. Regarding credentials, we need to create this token. In the security section we need to create this token and we need to save this in our Jenkins credential. And second one, we need to create an empty project for our project key purpose. here project name and project key. This project key we are going to use as environment variable in our static analysis process in pipeline. Okay, pipeline script. A third one, we have to set the security permissions, global permissions for that user we are going to use in this process. He must has this execute analysis permission. So make sure to have these permissions without fail, otherwise build will be failed. So regarding SonarQube, these tips are crucial. And coming to Nexus repository, already I said Nexus credentials are need to store in Jenkins credentials. Once we store these credentials, and next we have to save these credentials in the Jenkins Maven settings.xml file, because I'm using the Maven plugin in the Jenkins, right? I didn't use a separate Maven server. That's why I'm saying Jenkins, the Jenkins container, there is a Maven, this file is there, /etc directory, Maven directory is there. In that Maven directory, settings.xml file is there. In that settings.xml file, we need to add this servers block into that file. Like for our repository, we are going to store username and password environment variables. Then only it will going to deploy the artifact into Nexus repositories. Otherwise, it will going to fail. So for that purpose, we need to update this file, settings.xml file. We need to update. So generally, we don't have any permissions to edit any file in the Jenkins container itself, even though we are going to connect to it as a root, like using Docker exec -u root user. Also, we don't have we are unable to edit this file, right? So for that purpose, I have copied this file from this Jenkins container to my host, and once it is copied, I will edit this file, and I will add this server's information in that file, and I will copy this file once again back to the Jenkins container. So nothing is there here from the Jenkins container we are going to copy to our host. Once it is copied successfully, we can edit this file, and we have to add this servers block. This one only, already these settings servers, no need, let me delete this one, otherwise because you may get confused. Already servers block is there in that file, so we need to copy this block, we need to add to that file. Once it is successfully added, then we have to keep that file as it is. We have to copy the updated file into the Jenkins container directory. Once it is successfully copied from the host to Jenkins container, we have to restart our Jenkins container. Okay, if it is done successfully, then we can able to deploy our artifact into Nexus. Then only we can able to deploy our artifact into Nexus, otherwise build will going to fail. Okay, this is the regarding artifact credentials. After that, whenever we are going to push Docker images into private repository, like private registry like Nexus, we have to create a repository. Obviously, in that process, in Docker, in Nexus, there is one setting is there. Let me show you that one. Is Docker repository I have created a Nexus for storing my Docker images. Here we have to give one port number for allowing Docker HTTP. We have to specify a port number. With this port number only, we can login into Docker server, and so when we are going to use when we are going to push Docker images, we have to give this URL with this port number instead of 8088. Let me show you in the pipeline. See here, this is our Docker repository, right? To keep our Docker images, this is my Docker repository URL. Here we need to specify 8055. In general, this artifacts storing repository is 8088 port number is there, right? But for storing Docker images, we need to specify the port number at the time of creation of that repository. Okay, whatever the port number you have specified in this field, we have to give that port number instead of Nexus repository port number. Okay, please remember this, otherwise this pushing the images stage will going to fail. And Docker image also, for naming purpose also, we have to specify this registry IP and port number, and what is our repository and image name. Okay, so here also we have to give this port number only. Okay, please remind this one also. Let me show you a normal this artifact repository. Here we don't mention any port numbers. We can able to directly access this with our Nexus port number only. See here, this is 8088 I have set for this Nexus server. So with that port only we can able to access regular repositories which are going to use to store our artifacts. For storing Docker images, we need to specify different port number, and we have to use that port number only in our pipeline process. Okay, that is the another important step. Okay, once you have successfully created a repository in Docker Nexus for Docker, we can log in into Docker using this repository using hyphen username. Here we have to mention our username. Let me show you this one also. It will ask password, otherwise we can pass password also. See here, we are successfully login is succeeded. If you see this one only, the connection between Docker and Docker server and Nexus server is happened. Otherwise, if it is failed, means we are unable to push our Docker images from Docker server to Nexus server. Okay, Nexus repository. Okay, please remember that. And at the first time, once we have created a Docker repository in a Nexus, and we have to log in our Docker server using that URL. After that, we have to edit one file in the Docker server, which is Docker daemon configuration file. It is available in /etc/docker directory. In that /etc/docker directory, there is one file called daemon.json. In this file, we have to add insecure registries in this one, which is going to, we have to update this our Nexus repository IP and our repository port, what we have set here, that one we have to update here. We need to add this code into this file and update and save this file and restart the Docker server. Okay, excuse me. So these are the crucial steps we need to follow, otherwise this project it won't success. So let me show you Dockerfile also. This is the Dockerfile I have created regarding Docker image building purpose. So there are 3 stages in this Dockerfile. In the stage 1 we are going to pull one Maven image, and I have set this alias for this stage as build, and I have created a working directory for this stage, and I have copied this pom.xml, and I am going to download this all the dependencies which are necessary for our source code for deployment or building artifact purpose. And after that this is here we are not going to build artifact, just we are downloading the all the required dependencies. Okay, here we are going to copy the source code and we are building the artifact. Here I have skipped the test. In the later stages we will add the integration testing also. Okay, here once this artifact is built, in this we are going to move the second stage. Here in the second stage we are copying this artifact what it has built from the build stage to this stage by creating an argument for the jar file version. So copy -n from equal to build. This is the alias name we have set here. That means it is going to copy the artifact from the build stage to this stage. For here we have created a release, right? This one is release stage, like so. From here to it will copy that artifact from this. So in the app, in the target directory is there. From the target directory this jar file will be available. From that target directory it will copy that jar file to this image, like in the app directory what we have set in our working directory. In the final stage we are going to run this application. We are going to pull one small JDK image, and we are going to create one working directory. And here also we are copying the artifact from the release stage to here, and we are exposing this application port number here, and we are setting the entry point to run this application when the container is up and running. Once it is started, it is going to set this entry point, then only we can able to run this. Okay, this is the Dockerfile I am using for my project. Let me come to the pom.xml. This is pom.xml of my project. These completely have all the required dependencies, everything. This is the version I have mentioned here. This is a snapshot version. So these are the properties we have to set for JDK and JUnit, all these things. What are the required dependencies, plugins, information, everything, it will be there in this pom.xml. So Spring Boot Maven plugin configuration. This is a SonarQube Maven plugin and Jenkins Maven plugin for code coverage. Actually this is the Nexus repository block. Here we are going to use ID for the different repositories. One is Nexus release repository and another one is snapshot repository. Here also we are using the environment variables only. We are not exposing this Nexus server repository here. So like this we are going to use this pom.xml in our project. So all these files as of now I kept only pom.xml and Dockerfile in this GitHub repository. In the later part, in the later we'll try to keep these Jenkins file also in this GitHub repository, and we will enable the GitHub webhooks. Whenever there is a new code commit is there, this pipeline will be automatically triggered. Okay, we'll do that in later. Okay, so whenever there is a source code, this is a manual process, so that's why just only I have kept the Dockerfile, and pom.xml is necessary, right? Okay, so this is my project. I will share this documentation in my GitHub repository for your purpose. Okay. So in this way, we can create Docker containers to run a Spring Boot application, and which is used in MySQL. One more thing, let me show you the MySQL DB also. -it Jenkins. Let me go into the MySQL DB. Now I am in the Jenkins container. So I have prepared steps here, how to use MySQL. So here we have to log in MySQL DB. So this is the command docker exec it mysql db mysql. This is the container name, and this is MySQL shell. Okay, here user is root, and I have to mention the password. Whenever I use this command, it will prompt for password. We have to give password. Okay, see, we are successfully logged into the MySQL shell. Here we can get details like databases, show data, sorry, typo error. These are the databases present in this database server, MySQL DB server. This is the database which is used for our project login system. Okay, and we have to set this database. For that purpose, we have to use this one, use login system. That means by default some other database will be set. So to change that one, we have to use this command, use login system. Database is changed. Now we can check what are the tables present in this database. There are 3 tables in this database: roles, users, user roles. Let me show you. We have almost 7 users are there, right? Already we have registered, so we have to check the users information, it is stored successfully or not in this users table. This is the basic command, select star from users. As of now, nothing is there, right? Because I didn't use any volume, whenever I have this application is logged out, it is not going to save that information. So let me create one more user. So login, I have created user, right? Now I will check this one. See, just now I have registered an user. It is stored in this database. Like that, we can store a number of users. I'm creating some more users here. So if you run once again, see all the users data is stored in this users table. Like this we can test what are the roles are there, what are the roles. Is the roles table. There is only one role, admin role. So this is a small application. I have created admin role only. So like this we can access our SQL DB also. If you set a mount or volume for this database, so if you set any volume for this MySQL, we can retrieve the data even though application is closed. So let me exit from this one, exit from container also. Let me clear this one, Docker images and Docker containers. Let me show you our volume. Already I have used one volume for the Jenkins, so that's why I am persisting my Jenkins container data even though I am closing this container. Whenever there is a crash of that container has happened, I am persisting the data. So Docker volume ls, we can see this is the Jenkins home. This is the volume I have mounted to the from the local system to from the Jenkins container to local system. So this Jenkins home directory, what is going to store, everything will be stored, and it will persist the data even though any container crashes are happened. Like this we can create and run this application using containerization and Jenkins pipeline concept. This is my project. So okay, like this way we can implement another projects also. Thank you. Hi friends, in the previous video I forgot to explain about the Jenkins file, so let me explain this one. Yeah, in this first of all we need to declare some environment variables for each and stage. So let me briefly explain this one. This is the Spring Boot image variable, that is we are giving the name for that image, and container variable we are giving the container name, Spring Boot app container, and MySQL image. Here we have to mention the image what with the version which is useful for your project. Here I am used this MySQL 8 version. So and next I am going to create this variable for MySQL container name, and this is the database name which is used in our project source code. Same name we have to mention here for the MySQL database this variable, and this is the port number for MySQL, and this is the data source URL for the application, which is actually it should be equivalent to the application properties file, so it should be matched. So this is the JDBC MySQL and MySQL container name here, and MySQL port, and MySQL database, that is login _ system. So for the next variable it is Docker network. My network, this is the name I am going to create. This is the Spring Boot port number 8081, already we have mentioned in the Dockerfile also. This is the SonarQube URL, my SonarQube server URL, and is the Nexus Docker repository URL, and this is the Docker repository image, Docker image variable. So this is our Nexus repository URL, and this is our image name, Docker image name, and Coming to the next one, it is the release repo URL, Nexus release URL, and this is the snapshot URL. So let's go into the stages. In the first stage, it is going to clone the repository, source code repository from the GitHub using these credentials what we have created in the Jenkins credentials. Here I didn't mention any branch name because it will by default it is in the master branch only. If you want to pull the code from particular branch, we have to mention the branch name also here. In the next stage, I am going to create the network. It will check first if there is any network is present with the same name. It won't create. If it is not there, then only it will going to create. Here we are testing if not. Okay. In the next stage, it will create and run the MySQL DB container. Before that, it will check. It will use the credentials what we have stored in the Jenkins container, Jenkins credentials. So here it will test. It will check for if there is any container name there, the same name. Then if it is any container is there, then it will stop the container and it will remove. Then only it will going to create and run this MySQL DB container using all the necessary variables. Already you know what is the command, how to create this container. So here we are using the database environment variables and image name here. So this is the stage where we are going to create MySQL DB container. Once it is created, it will wait for some more time to check whether that container is up and running or not. Once it is successfully created and it is in up and running state, then only it will go into the next stage. In the next stage, it is we are building the Docker image here using the Docker based on Dockerfile. It will going to build the image. So once our Docker image is successfully built, then it is going to create our application container based on this image using the credentials of MySQL DB, because we are going to attach the MySQL DB with our application, right? And it will check for is there any container with the same name we are going to create. Then if it is there, it will stop and it will remove that container, and next it will create that container and with all the necessary variables. So here this is the data source URL, and this is the database data source username, password, and the port number, and what is the image we are going to use for this application container. Once it is created successfully, created and running state, it will check it will verify the application status, it is running and successfully or not. Here we are using the curl command to test our application. This is the application IP, the port number, and here if it is okay, it's running successfully, means it will go into the next stage, otherwise it will fail the build and it exists from here. Once it is successfully running, it will going to do the testing in this stage. Here we are doing the ambient clean test. Excuse me, some noise is there. Once testing is completed successfully, then the next stage it will going to perform the SonarQube static analysis. Here in the same manner as above, it will use the environment variable SonarQube like in the configuration, Jenkins configurations, already we are going to set the SonarQube URL, right? So it will use the SonarQube environment variables with the credentials. It is the URL it will get, and it is the token, SonarQube token, it will get from the Jenkins credentials what we have stored earlier. Is the SonarQube token. Based on these credentials, it is going to it will going to perform the static analysis using ambient clean verify sonar. This is the project key what I have explained earlier in the Sonar server. Whenever we are going to create a project, that is the name we have to mention here as a project key, and it will get the SonarQube URL. Already we have declared in the environment variable section. It will get the SonarQube token from the credentials, and it will perform this static analysis. Once this is completed successfully, it is going to the next stage. It is the deploying our artifact into Nexus repository. Here also same, it will get the version from the pom.xml based on URL. It will test if it is that is version ends with -snapshot. It is going to pick the snapshot repository. Otherwise, it is going to pick the release repo. And regarding repository ID also, if it is version is ended with snapshot, it is going to pick the Nexus snapshot ID from the pom.xml. Otherwise, it will going to pick the Nexus releases ID, which is there in this here. So in this section, this is the ID. Based on this ID, it is going to pick this repository, right? Here also it will going to use the credentials what we have stored in the Jenkins credentials, username and password. Based on those credentials and these variables, it is going to deploy our artifact into Nexus repository. Based on the version, it is going to choose the right repository, and it will deploy our artifact into that particular repository. Once this deploying artifact into Nexus repository is completed, then it is going to push our Docker image what we have built earlier stages to the our Nexus repository. Already I have explained the process how to set the repository for Docker images, and we have to enable the port number, and we have to docker daemon.json file, we have to update it with our Nexus repository IP and port number. So then only we can able to maintain the communication between the Docker server and Nexus server. Otherwise, it is going to fail. So here also it is going to use the Nexus credentials same as above, and using that it will create the tag first using the Spring Boot image and Nexus Docker image variables. It is going to give that version as latest. And here once it is that once tag is created, it will connected to the Nexus repository from the Docker server using this Docker login command. Here we are using the Docker repository URL, and we have to mention our username and password from the standard instruction input. Whenever it is here directly we are getting the password. So once it is logged successfully, then it will push into that it will push the image into that Nexus repository by using Docker push command. So in this way, it will perform the pushing the Docker images to Nexus repository. Once all the stages are successfully completed, then it will perform the cleanup process. So it will remove the dangling images and unused images, and it will delete the unused volumes which are created in this process to clean up the to get the unused space to utilize further. Once it is once it is completed, then it will we have post section here. In the post section, always block is there and failure block is there. One always means even though it is failure or success, it will perform this what are the tasks we have mentioned here. It will clean up the Jenkins workspace. If it is failure means it will display the message like pipeline is failed. Okay, this is Jenkins pipeline what I have created to run this application, this project successfully. So that is the friend. Okay, thank you. I will share all these documents in my GitHub repository, and for your reference purpose. You can do your own, you can do this project your own. Okay, thank you very much.